This Zoom session is being brought to you by the fractal Bullseye Fire Right. All right. Today we continue with inverse trigonometry for inverse cotangent, inverse secant, and inverse cosecant, and also about how to calculate trig functions of arctrig functions. All right, we start with, okay, cotangent and tangent are inverses, and arctangent of 1 over x is the angle whose tangent is 1 over x, and therefore whose cotangent is x. So arctangent of x is arctangent of 1 over x. Similarly, because secant and cosecant are reciprocals and cosecant and sine are reciprocals, the arcsecant of x can be defined as the arccosine of 1 over x. The arccosecant of x can be defined as the arcsine of 1 over x. Because these are multi-branched functions, because the tan, cosine, cotangent, secant, and cosecant aren't one-to-one, therefore really can define many inverse functions, but these work fine. All right. Now, here we're talking about trig functions of arctrig. So, I mean, for example, sine of arcsine of x is just x. Cosine of arccosine is x. Of x is x. Tangent of arctan x is x, as befits an inverse function. But here's cosine of arcsine, tan of arcsine, sine of arccosine, tan of arccosine, sine of arctan, cos of arctan. How does it work? Well, these right angle triangles give you sufficient clues to how to work it. Here is a triangle with a right triangle with opposite side x and diagonal 1. Therefore, this angle here at the base, opposite the x, is arcsine of x. Now, from 1 here along the long side and x here along the short side, by Pythagoras, you can quickly determine that the other short side is square root of 1 minus x squared. And then from that, we can immediately read off the trig functions, the other trig functions of arcsine. So cosine of arcsine is adjacent over hypotenuse, therefore 1 minus x squared. Tangent is opposite over adjacent, therefore x over 1 minus x squared. Here we have sine and tangent of arccosine. So here's a right triangle with adjacent side x, diagonal 1. And so therefore this angle is arccosine x. The opposite side is root 1 minus x squared, again, derived quickly by Pythagorean theorem. And then we read off, sine of arccosine is opposite over hypotenuse, therefore root 1 minus x squared. Same as cosine of arcsine, you'll notice. And tangent of arccosine is opposite over adjacent, therefore root of 1 minus x squared over x. And it just occurs to me that these two are reciprocals, whatever. Now here we have trig functions of arctangent. So here's a right triangle with opposite side x, adjacent side 1. So this angle at the base here is arctan x. The third side by Pythagoras is root 1 plus x squared. And you have to watch out, here's a plus here because it's the diagonal. And back here, it's root 1 minus x squared because it's the short side. Okay, so we read it off right away. Sine of arctangent is opposite over adjacent. X over root 1 plus x squared. Cosine of arctangent is 1 over root 1 plus x squared, like that. So, and the virtue of these figures is that it enables you to remember these formulas without going to the trouble of memorization. You just have to remember how to write the triangle. So here's some examples. What is cosine of arcsine root 2 over 2? Well, here's a right triangle, and sine is opposite over adjacent, root 2 over 2. The third side, the other short side is root 2. Cosine, and so this is the arcsine of root 2 over 2. 45 degrees, of course. And cosine is adjacent over hypotenuse, root 2 over 2. Tangent of arccosine minus root 3 over 2. Now this minus means we have to go to the planar definition of the trig functions. So arccosine minus root 3 over 2. We go back to an x coordinate of negative root 3 out a distance 2. This third side is by the 30, 60, 90 triangle equal to 1. So this point is at negative root 3 by 1. And so this is the arccosine of minus root 3 over 2. Tangent is opposite y over x, opposite over adjacent, negative 1 over root 3, and you can rationalize that to minus root 3 over 3. Here's cosecant of arctan 1. All right, so we have right triangle with sides 1 and 1, opposite and adjacent. So this is arctan 1, which is, of course, 45 degrees. The diagonal is root 2. Cosecant is adjacent over opposite, root 2 over 1, which is root 2. And here we have cosine of arcsine root 3 over 5. It's similar to one of the ones in the book. Okay, right triangle. Opposite over adjacent is root 3 here, over 5 here. Now find the third side. We take square root of 5 squared minus root 3 squared, which is the root of 22. So cosine is this adjacent over this diagonal, root 22 divided by 5. Now these are a bit redundant. We've already did these two up here, but I'll do them again. Sine, well, actually, no. This is arc cosecant and arc secant and arc cosecant. So it's actually not quite that redundant. So where was I? Okay, here, we're starting here. Cosine of arc tan u. So here's an angle, arc tan u, opposite over adjacent. So u here opposite, 1 here adjacent. Diagonal is root of u squared plus 1. So cosine is adjacent over diagonal, 1 over root u squared plus 1. Tangent of arc sine. What's that? Okay. So here's a right triangle. Here's the angle arc sine u, which is opposite over a diagonal. Then the third side is root 1 minus u squared. And tangent is opposite over adjacent, u over root 1 minus u squared. Now here we're dealing with this arc secant and arc cosecant, so it's not quite that trivial. But we still can use the triangles. So sine of arc secant, what's that? Well, so we have so here we have an angle of arc secant of u, which is also arc cosine of 1 over u. Arc secant is one where diagonal over adjacent equals 1. So put a u here and a 1 here. And so this angle will be arc cosine of 1 over u and also arc secant u. Fine. Diagonal u, side here 1, the other side is the root of u squared minus 1, again, by Pythagoras. So, all right. So sine is opposite over a diagonal. So root u squared minus 1 divided by u. Here's cosine of arc cosecant of u. All right, so here, this angle will be arc cosecant of u, which will be the same as arc sine of 1 over u. Arc cosecant will have diagonal u is diagonal over opposite. So put a u here and a 1 here. And then, oh dear, oh dear, oh dear, oh dear, I have to, error, big error. I'll have to fix this. This side here is not root 1 minus u squared, because since u is bigger than 1, this will be an imaginary quantity. In fact, I have this backwards. And this should be root of u squared minus 1 here, like here. And so really this should be root of u squared minus 1, that divided by u. I shall fix that in the canvas. So be it. All right, so that's where that is.